Hi, welcome to this lesson on right-angled trigonometry. So we've spent a few lessons looking at the tangent ratio, and this is what we know so far, that when we're looking at right-angled triangles we can name the three sides, and it's all to do with the position of the right angle and also the kind of angle that we're working with, which either we know or we're trying to work out. We've got this hypotenuse, opposite adjacent side, and what we learned was that the ratio of the opposite to adjacent side for a particular angle is always the same. If you remember back to the first lesson, if you were working with me, we did this idea of saying that if you've got a right angled triangle and if you enlarge it any times that you want, this first one has been enlarged by a factor of 2 and 3. And what we found was that these two sides, what later became known as um, the opposite and adjacent, we called it the kind of base and the height, were always gave us the same ratio. So in other words, I'm just trying to find my highlighter. So the kind of 3 and 5, 3 divided by 5 is 0.6, and 6 divided by 10 is 0.6, and 9 divided by 15 is 0.6. And we found that they were all attached to the same angle. In other words, kind of 31 degrees was the kind of angle inside here. So what we found was that we could say that the tan of 0.6 is 31, say it the right way around, we could say the tan of 31 degrees is 0.6. The tan is just our mathematical kind of code for saying we're looking at the opposite divided by the adjacent side. So if we divide opposite by adjacent, we get 0.6, and that's attached to the angle 31 degrees. Your calculator's got all these things stored in it. And that's why we've been using the tan ratio all this time. But the interesting thing is, of course, that you can make a ratio of any two sides, not just the opposite and the adjacent. So let's have a look at the idea of one of the other ones. So if I were to take the opposite side, which is the 3, and the hypotenuse, which is 5.8. So if I do 3 divided by 5.8, I'm going to get a different answer to 0.6. So let's just check and see. If I do 3 divided by 5.8, then that would give me, on my calculator, 3 divided by 5.8, 0.52. Okay, 0.52. Now that, according to this is the angle we're looking at here. So now that we know the names, that's the opposite, and this is now the hypotenuse. That's now opposite and hypotenuse. Notice we've got a different ratio going on there. And if we take the second triangle here, this time 6 divided by 11.7, if you did that, the opposite divided by the hypotenuse, 6 divided by 11.7, still gives us 0.51. It's just measuring error, really, because of the way I had measured the third side there. It's basically about the same, 0.51. And if you look at the third triangle, if we do 9 divided by 17.5, opposite divided by hypotenuse, we get 9 divided by 17.5, we get 0.51 again. Okay. In other words, we can apply the same principle as we did with tan to this other ratio of opposite over hypotenuse. Okay. In other words, your calculator has that one as well. Now, it so happens that, of course, it's still connected to 31 degrees. We can't call it the tan of 31, so we give it a different name. Okay, so let's have a look at what the names we give to this. Let's have a look at this diagram here. So what we're going to do is we're going to construct the new ratios. So what we know is that the tangent ratio is, what have we got, is we call it tan, and we'll call it tan equals tan x equals opposite over adjacent. We know that. Okay. Now the other names that we can do, what happens is we'll call it the sine ratio. All right. Now that's the one we were just looking at there. Its short hand is just sin, sin, but we pronounce it sine, and that ratio was the opposite We divided it by the hypotenuse this time. It's the same idea, but because it gives us a different number, which connects it to 31 degrees, we have to call it something else. So we call it the sine ratio. Okay, and the other one, which we hadn't thought about yet, but we can go back and think about it. What happened if we used the 5 and the 5.8? What happens if we use the adjacent and hypotenuse as our pair of bits of information? Well, we can do that as well. Okay, and we call that the cosine ratio. So the cosine ratio, which is abbreviated to cos, is simply when you take another pair of sides, and that pair is the adjacent divided by the hypotenuse. Okay, so what we've actually got are three formulas that we can use, and it just depends on which two sides we're working with. We don't always have the information to use the tan ratio, and so we've got to be flexible. Okay, so I'm just going to recap that on this screen here. We know already that tan x is opposite over adjacent. We're now saying that sine x is the opposite side. Well, sine x is the opposite side divided by the hypotenuse, and cos x is the adjacent side divided by the hypotenuse. And there's our three formulas, which is really good to write down. Let's go take a note because we're going to be using these all mixed up. The great news is that all the things that we've learnt to do, calculating sides and angles, we can use with any of these three formulas. We're just going to have to, the key difference is when we use our calculator, we have to press a different button, and hopefully if you've noticed that cos and sine are right next to tan on your calculator. So it's just important that you press the correct one of these three depending on the ratio that you're using. Okay, so let's have a look at this in practice. Right, so example 1, calculate the height of this right angled triangle. Now, according to our trigonometry so far, the first thing we do is we label our sides. Opposite the right angle is the hypotenuse. Opposite the marked angle, which is 27 degrees, is the opposite, and the other side is the adjacent. Okay, so now let's look at this, because we can't automatically write tan x equals opposite over adjacent as we did before. We're going to have a look at the information that we've got. Do you notice that we actually have a number on the hypotenuse side, and we have a letter on the opposite side? So we want the formula, we want the ratio that's got opposite and hypotenuse. Which one is that? Well, if you've written them down, you'll be able to see. Let's flip back. Opposite and hypotenuse is the sine ratio. So we're going to write down that formula. Okay, so let's do it. So we write down sine x equals opposite over hypotenuse. It's exactly the same form, so what we do is we substitute in the three things that we usually do. So x is the angle, which in this case is 27 degrees. The opposite is the letter h, and the hypotenuse is a number 42. Does that look familiar? Hopefully it is. We've got to try and get h on its own. It's divided by 42, and so what we do is, just as we did when we were using tan, multiply by what's on the bottom of the fraction on both sides. So that leaves me with 42 times the sine of 27 degrees is equal to h, because remember they cancel out. H, therefore, is just going to be those two numbers multiplied together, and that's where you just have to watch it with your calculator. So it's 42 multiplied by sin 27 this time, and not tan. Press equals, and we just do as we normally do. Write down what your calculator says, 19.067, and round to whatever would be helpful. So round it to one decimal place. The 6, which we're going to cut off, tells us to round up. So h is 19.1. You put your units of measure, centimetres, to one decimal place. So there we have solved a problem using one of the other ratios by identifying that we need the formula that's got opposite and hypotenuse. We look at the three of them, choose the right one, and then we use it in exactly the same way that we used tan. Okay, let's try a second example. It says here, calculate the length of the line AB. Okay, so length of line A to B is this sloping line here. rather than using capital AB, I'm going to go and put a letter in it, just to, I'll call it D for distance. Okay, so I'm going to work out the length of what is small d rather than capital AB. I'm going to label my sides. So opposite the right angle is the hypotenuse. Opposite 63 is the opposite, and then we've got the adjacent here. Okay. So what do? We need to have a look at now, rather than just assume it's the one formula. We've got to now say, what rule do we use? And we'll talk a wee bit more another lesson about how we remember them, but you'll have them written down just now. Look at what we've got. We've got 7 meters on the adjacent side, and we've got the letter on the hypotenuse side. So we need the rule that's got hypotenuse and adjacent in it. We need hypotenuse. Let's flip back. Which of the rules has got hypotenuse and adjacent in it? Well, this one here. Okay, cos x, cosine of x is adjacent over hypotenuse. So we're going to go and write that one down. Let's do it. So cos x, cosine of x, is equal to the adjacent side divided by the hypotenuse. So now the only difference is we're using the cosine ratio rather than sine or tan. So we go ahead and substitute in what we know. X, the angle is 63 degrees. The adjacent side is marked as 7, and the hypotenuse is D. Okay, so this is the other situation where we're dealing with the letter on the bottom of the fraction. So what do? We just multiply both sides by what's on the bottom of the fraction, because they're going to cancel out. What does that leave us with? Well, on the left hand side we've got D times the cos of 63, and on the right hand side we've got the number 7 on its own. We had to do that extra bit of working this time, which is that we're going to divide each side by cos 63 in order to cancel that out and be left with D. So we divide both sides by cos 63, which means we're ending up with D is equal to 7 divided by the cos of 63. Now you've done that when you were practicing using the tangent ratio. We've done that over and over, finding a side with the letters on the bottom of the fraction. So hopefully that should be familiar to you. Take your calculator. 7 divided by the cos of 63. So you're pressing the cos button this time. Please remember 15.418. 15.418. You're going to, we'll cut it, just keep working to one decimal place just now. The 1 tells us to round down. 15.4 meters to 1 decimal place. Now, I used the letter D just as a wee kind of shortcut for me. The question said calculate the length of AB. So I always have to finish by answering the actual question I was asked. Okay, so even though I used the letter D, that was just for my benefit. So we have to always answer the question as it was asked. Length of AB is 15.4 meters. Okay, so that's us introduced the new ratios, and it's really important that you get that. It's important that you copy down those 3 formulas so that when you come to then deciding what you label the sides on your triangle, you've got to choose the correct one, and that's the really important thing, choosing the correct formula so that you can then get the correct answer. So let's practice that and see how you get on.